What's up, mathematicians? Justin here, and welcome back to our unit on measurement. This is lesson number three, and in this lesson, we'll look at how you could use the tangent ratio to measure the height of a tree. Now, this might remind you of the last lesson, and if you recall, in the last lesson, we talked about proportionality and similar triangles, and we used those concepts to show how you could indirectly find the height of a tree using the length of its shadow. Now, the technique that we're using in this lesson is one that you could use to find the height of a tree even on a cloudy day. Now, before we get into that, I want to talk about a few assumptions that we made in the last lesson. And we'll start by looking at that definition. If you recall, I gave you this definition of similar triangles, okay? I said that two triangles are similar if all their corresponding angles are equal and all their corresponding sides are proportional. Now, it turns out that the first part of that, all corresponding angles are equal, that is enough to necessitate that the two triangles are in fact similar. Okay, so that's the first assumption that we're making. Okay, we're assuming that similar triangles exist. That it's possible to have two triangles of different sizes, one bigger than the other, where both triangles have all corresponding angles equal. Okay, so those two triangles would be similar. Then we threw this other thing into that definition as well. We threw that if all the corresponding sides are equal, all the corresponding angles are equal and the two triangles are similar, then the second thing has to be true as well. Their corresponding sides are proportional. Okay, and for this lesson, for today's lesson, we're going to add a third assumption to this list, and that assumption is this. We're going to assume that all right triangles have the same angle sum. Now, we kind of actually implicitly assume this already in some of the problems that we did in the last lesson, but now we're going to be explicit about it, that we are making this assumption. We're going to need this assumption to build up this tool of using the tangent ratio in today's lesson. Okay, so we're going to assume that all right triangles have the same angle sum. But wait a second. Speaking of angles, that's another thing we can measure. In fact, angles are the thing that I didn't mention in that intro to measurement lesson. If you recall, I said there's one thing that we measure all the time in geometry that I'm not measuring. Well, what is it? It is angles. So if you were able to guess that, then that's correct. So I want to show you a few devices before we go on to the measurement side of it. I want to show you a few devices that you could use for measuring angles. And actually, the first one I'm showing you is not a measuring device at all. So this is not a device you can use to measure angles, but I would call this more of an indicator. Okay, this is a level that you can use when you're doing construction type work. And what this level will show you is if a surface is level, if it's horizontal, you can also use it to indicate if it's vertical, which is perpendicular to the horizontal. And this one also enables you to determine if it's at sort of a 45-degree angle. Now, this device is certainly not giving you a number, right? So when we talked about measurement, we said measurement is the practice of assigning a number to a magnitude. Now, angles are magnitudes, but this device cannot assign a number to the magnitude. It can just indicate, is the magnitude, flat? In other words, in which case we would say 0. Is it perpendicular at a 90-degree angle, or is it at a 45-degree angle? Okay, but connected with this device, I have another one that I use sometimes when I'm doing construction type work. And this is kind of a level as well. I don't know how well, maybe if I put it here in front of my face, it'll come into focus. There it is. So basically, this one does assign a number to the angle. So when you turn it, you can see different numbers show up there. So it's not just saying if it's level or not, it's giving you the angle. So I place it on here, and it's saying that, yeah, this is within about 1/10 of a degree of level. Angle it up, and it'll tell you the angle above level that it's tilted at. Okay, so this is our first device that I'm showing for measuring angles. However, the device that you will typically be using in this class to measure angles is this one right here. Let's see if I can get in focus. Yeah, right there. So this is called a protractor. And this device can be used to measure angles on a sheet of paper. So let's look at that. So here it is. You can see that it measures in both directions from 0 up to 180 degrees. Now, if you don't have a protractor and you're going to buy one, I do recommend that you actually get a small one like this rather than the larger ones with a sort of half circle hole in the middle. These are accurate enough, and it's a lot easier to measure angles on non-Euclidean surfaces using this type of protractor. But anyway, yeah, so this is a device that will assign a number to a magnitude, the angle. Similar to this one, I have another type of protractor to show you. That is this digital protractor. Okay, so this one here, I'll turn it on, and oops. Oh, there it goes. Okay, so I can basically move it like this, and you'll see the angle changes. So I can use this to measure angles a bit more precisely than I'm able to measure with this device. So for example, let's see, I've got my triangle here, and I could just measure the angle of this triangle, and let's see what it is. I'm going to work right up to, oh, well, what do you know? It's 30 degrees, which is good because this triangle, this angle on the triangle is supposed to be the 30-degree angle. And sure enough, we have 30 degrees right on the dot. So that's another device we can use for measuring angles. These two right here, sort of two different types of protractors. Now, the last device I want to show you for measuring angles is this one right here. Pick it up off my shelf. This is a transit level, and let's see if I can get that one in focus for you. Right there. Oh, okay. So this is basically a surveying device. This is an older one. I bought this one on eBay a couple of years back as, I don't know, something that I thought would be interesting to play around with. There are much more expensive and accurate ones than this, but this is good enough for my educational purposes. And this particular device is used for measuring angles of elevation and angles of depression, which, by the way, you could also use this device right here to measure those angles of elevation and depression. The angle of inclination is basically the same thing. So let's look at what that would look like. So what are angles of elevation and angles of depression? Well, it's simply this, okay? So from the perspective of some observer, and you see, you know, this little, basically the eye level of some observer, if you're looking straight ahead, that's horizontal, right? So you have this horizontal level. An angle of elevation is the angle above horizontal. So if there's an object that you'd have to look up to, the angle of elevation is the angle that the line of sight would make to that object with the horizontal line. So basically, you know, if I set my bubble level to here and I tilted it up at an object and I'd see, oh, there it is at the object, then I could look, and you can't see it's on the other side, but I could look and see the angle of elevation right here. Similarly, if there was something below horizontal that I looked down at, the angle that I'm looking down at would be an angle of depression. So here I got my bubble level, I'm looking down at some object, and the angle that I'm looking down at, that is the angle of depression. Okay, so those are just a couple terms for you to be aware of, and also some examples of devices that we can use to measure angles. In the next video, my daughter and I are going to be outside using this transit level and also using this large measuring tape to take a couple of measurements that we can use to find the height of a tree using the tangent ratio. So hope you will watch that one, and thanks for watching. Bye-bye.